Welcome to the course of differential equation. In this session, we will discuss about the Euler-Cauchy equation part 2. In the first part, we discussed about it is that the general form of the Euler-Cauchy equation x square y double dash plus a xy dash plus by is equal to 0. Okay. So, this is Euler-Cauchy equation, general form of the Euler-Cauchy equation, and here we have the auxiliary equation is m square plus a minus 1 into m plus b equal to 0 is the auxiliary equation. If the since the auxiliary equation is a quadratic equation, there have three choices for the roots. Because their discriminant is positive, it can have real and distinct roots. On that case, we will have the solution y is equal to. In this case, we will have the solution if b square minus 4ac is greater than 0. B square minus 4ac is greater than 0. In this case, we discussed it is general solution as y is equal to c1 x raised to m1 plus c2 x raised to m2 is there. Here b square minus 4ac is the representation, stands for only the quadratic equation am square plus bm ax square plus bx plus c, or am square plus bm plus c. Here this is equal to, in this case a is equal to 1, b is equal to a minus 1 and c is equal to b is there. Okay, fine. Okay, this we discussed in the last session, and now our thought, what will happen if b square minus 4ac is equal to 0. Say my dear students, this is equal to m square plus a minus 1 m plus b equal to 0. So, if m is equal to minus b plus or minus root of b square minus 4ac divided by 2a is here. Okay. Here b square minus 4ac is equal to 0, that is this will be equal to 0. So, on that case m is equal to minus b divided by 2a. Okay. See my dear students, here minus b by 2a, but actually we discussed it is ABC stands for this equation, a is equal to 1, b is equal to a minus 1, c is equal to b. So, we have here b is equal to a minus 1. So, we will have the value is equal to 1 minus a and a is equal to 1. Therefore, m is equal to minus b, that is 1 minus a. 1 minus a divided by 2 is the double root. Okay, fine. Now, there exists the double root. Now, see my dear friends, how can we solve, what is the general solution of this kind of Euler-Cauchy equation? If the auxiliary equation has a double root, then the general solution will be the formula, the general solution, therefore, the general solution will be y is equal to c1 plus c1 plus c2 log x plus c1 plus c2 log x into x raised to m. Okay, fine. See, this is the general formula for the to find the general solution in the case of the auxiliary equation of the Euler-Cauchy equation has the double root. We can move to a problem. Example 1. Solve the differential equation. Solve the differential equation x square y double dash y double dash minus 3xy dash plus 4y is equal to 0. Minus 3xy dash plus 4y is equal to 0. Plus 4y is equal to 0. Can put this as equation number 1. Say while seeing this equation itself, we understood it is that is an Euler-Cauchy homogeneous differential equation. Say here we have the value of a is equal to, we have a is equal to minus 3 and b is equal to 4. Okay. We will write the auxiliary equation. The auxiliary equation is the auxiliary equation is a, that is m square plus a minus 1 into m plus b equal to 0. Find m square plus a minus 1 into m plus b equal to 0, that is equal to m square plus a, the value of a minus 3 minus 1 into m plus b equal to 4 equal to 0. Okay, fine. Therefore, we can write this is equal to m square plus a minus 1 minus 3 minus 1 minus 4m. Therefore, this is equal to minus 4m, and finally plus 4 is equal to 0. Therefore, plus 4 is equal to 0. We understood this is that m square minus 4m plus 4 is equal to 0, that is equal to m minus 2 whole square is equal to 0. Find that this implies this is equal to value of m is equal to, value of m is equal to 2 is a double root, that is a double root. Value of m is equal to 2 is a double root for the auxiliary equation of the Euler-Cauchy equation. So, see we have if we have double root, we have solution is c1 plus c2 log x into x raised to n. Therefore, the general solution is the general solution of given differential equation is y is equal to c1 plus c2, okay, log x into x raised to m, log x into x raised to m. Okay, fine. That is y is equal to c1 plus c2 log x, that is equal to c2 log x into x raised to m, the value of m is equal to 2, that is equal to x square. This is the general solution of the given Euler-Cauchy differential equation. Now, see this is the general solution of the given Euler-Cauchy equation. In this Euler-Cauchy equation, we know this is that the auxiliary equation has a double root. Please write down the next question, as this is equal to solve the Euler-Cauchy equation. Solve the Euler-Cauchy equation. Solve the Euler-Cauchy equation. X square y double dash plus 7xy dash plus 9y is equal to 0, plus 7xy dash plus 9y is equal to 0. We put it this is equation number 1. Say here while seeing itself, we understood this is that this is look like a this one Euler-Cauchy equation look like the standard form of the keeps the standard form of the homogeneous Euler-Cauchy equation. So, definitely that is a Euler-Cauchy equation. As because this is a Euler-Cauchy equation, the value of a is actually, this is a is 7 and b is 9. Okay, fine. Therefore, as part of solution, we can write the Euler auxiliary equation. The auxiliary equation is auxiliary equation is? The auxiliary equation is actually m square plus a minus 1 into m square plus a minus 1 into m plus b equal to 0. Find m square plus a minus 1 into m square plus a minus 1 into m plus b is equal to 0. Fine. So, m square plus a minus 1 into m, the value of a is equal to 7. So, we can replace the values. Therefore, the auxiliary equation is m square plus 7 minus 1 6m plus b is 9, sorry, plus b is equal to 9 is equal to 0. So, dear students, m square plus 6m plus 9, that is equal to m plus 3 the whole square is equal to 0. You may if you try to expand m square plus 2 into m 6m plus 3 square, that is equal to 9. So, m plus 3 whole square equal to 0. So, from here we understood it is that, therefore, m is equal to minus 3 is a double root, of given Euler-Cauchy equation. Euler-Cauchy equation of given Euler-Cauchy equation. See, my dear students, as because that is a double root, we have general formula for the general formula. So, therefore, general solution is, we have formula for the general solution. Therefore, general solution is y is equal to c1 plus c2 log x e raised to, sorry, c1 plus c2 log x x raised to m, x raised to m. Fine. c1 plus c2 log x x raised to m. Therefore, this is equal to, that is equal to c1 plus c2 log x into x raised to m is x raised to m, value of m is equal to minus 3. This is the general solution of the given differential equation. Fine. Okay. So, in this case we have Euler-Cauchy equation. Now, our thought it is that we discussed it is that the generally we have the second order homogeneous Euler-Cauchy equation as x square y double dash plus axy dash plus by equal to 0, and whose auxiliary equation is m square plus a minus 1 into m plus b equal to 0. Whose roots are maybe the b square minus 4ac, b square minus, we discussed b square minus 4ac is greater than 0, and also b square minus 4ac is less than 0. Here a is equal to 1, b is equal to a minus 1, and c is equal to b, that we already discussed. So, these two are we discussed. Whenever the b square minus 4ac is greater than 0, there will be two distinct real roots, and whenever b square minus 4ac equal to 0, there will be a double root is there. There is a single real root will exist here. Now, the finally we have to discuss if b square minus 4ac is less than 0. B square minus 4ac is less than 0 means b square is equal to, that is equal to, that implies a b square is a minus 1 whole square, a square minus a square minus 2a plus 1 minus 4a is less than 0. That means this implies a square minus 2a minus 4a minus 6a, sorry, minus 2a minus 4a, that is a minus 1 whole square, that is equal to minus 2a minus 4a, that is equal to a square minus 2a plus 1, minus 4ac, the value of c is equal to b. Fine. A square minus 2a plus 1, sorry, okay, this is enough. Fine. A square minus 2a plus 1 minus 4ab is less than 0. Okay, this is equal to b, value of b square is equal to a minus 1 whole square, a square minus 2a plus 1, that is equal to minus 4 into 1 into value of c is equal to b, that is equal to minus 4ab, the value of a is equal to 1 minus 4b is there. Therefore, a square minus 2a plus 1 minus 4b is less than 0. On that case, we will have the negative values there in this this one. Therefore, we can say that there will be the solutions of the auxiliary equation. So, there exists a complex conjugate root, a complex conjugate root, that is m1 equal to mu plus I nu and m2 is equal to mu minus I nu. Mu minus I nu is there. So, here mu is the real part and nu is the imaginary part. So, there is a complex conjugate roots. Then the general solution will be m is equal to mu plus or minus I nu, x y is equal to x raised to mu into a cos nu log x plus b sin nu log x is there. So, we can consider this as a general solution of that such kind of the Euler-Cauchy differential equation. If their auxiliary equation has complex conjugate roots, Okay, fine. See, my dear students, we can move to a question. Write down an example. Example 3. In example 3, our question is to solve the differential equation t square y double dash. Solve the differential equation t square y double dash minus plus 7ty dash plus 13y plus 7ty dash plus 13y is equal to 0. See, my dear students, instead of x here we used the variable independent variable as t. So, just we used independent variable as t. So, x instead of x square y dash, here t square y dash is there plus 7ty dash plus 13y is equal to 0. See, dear students, so we can write the value of a. This is value of a is 7, value of b is 13. Fine. Therefore, the auxiliary equation is, as part of the solution we will write the auxiliary equation as the auxiliary equation is okay. I have to write the auxiliary equation. We have a pattern, a format for the auxiliary equation as instead of this is m square plus a minus 1 into m plus b equal to 0, that is the auxiliary equation. See, dear students, m square plus a minus 1 into m plus b is equal to 0 is the auxiliary equation. So, we can replace the values as m square plus a minus 1, a is 7, 7 minus 1, 6m plus b 13 is equal to 0. Okay, now we can redefine this as a new quadratic equation with a is equal to 1, b is equal to 6 and c is equal to 13. Okay, fine. In this new quadratic equation, we can write, we can find the value of m by using the formula m is equal to minus b plus or minus root of b square minus 4ac divided by 2a. Fine. Therefore, m is equal to minus b, the value of value of b is equal to 6, minus 6 plus or minus root of b square 6 square minus 4ac, that is equal to minus 6 plus or minus root of b square, that is equal to 6 square, that is 36 minus 4 into value of a is equal to 1, value of c is equal to 13, divided by divided by 2a, that is 2a is 2 into 1. Fine. Okay, the value of c is equal to 13. Fine. So, we can write this is equal to, that is m is equal to minus 6 plus or minus root of 36 minus 4 into 13, 40 into 12, that is equal to 52. Okay. 52 divided by 2. Okay, fine. Now, see, minus 6 plus or minus 36 minus 52, the value is, this is equal to m is equal to minus 6 plus or minus root of 36 minus 52, 36 minus 52, that is equal to 16. Therefore, that is equal to 16 root of 16 by 2, root of 16 divided by 2. Fine. So, this is equal to 36 minus 6 plus or minus, minus 6 plus or minus, this is minus 16, because that is minus 16, because this is 36 minus 52. As since 36 minus 52, therefore, the 16 is minus 16. Here inside root the minus 16 is there. Therefore, I root 16 divided by 2. Thus, this is equal to minus 6 plus or minus root of I root 16 for I divided by 2. That is equal to, we can take a 2 is out. So, this is equal to 2 into minus 3 plus or minus 2I divided by 2. Fine. So, you can cancel 2 and 2. So, finally, we will have minus 3 plus or minus 2. So, therefore, we have m is equal to, m1 is equal to minus 3 plus 2I and m2 is equal to minus 3 minus 2I are the roots of the auxiliary equation. Are the roots of the auxiliary equation this one m square plus 6m plus 13 equal to 0. So, we found the roots of auxiliary equation as complex conjugate roots. Fine, because that complex conjugate roots with the real part is minus 3 and imaginary part is 2. So, we can have the general solution. Therefore, the general solution of the equation is, therefore, the general solution of the Euler-Cauchy equation is, the general solution of given Euler-Cauchy equation is, given Euler-Cauchy equation is, the general solution of the given Euler-Cauchy equation is, actually this is equal to, we have the formula here, we already discussed the formula. Okay. The formula is x raised to mu, where mu is the real part, a cos nu log x, where nu is the imaginary part, b sin nu log x. So, we have this is equal to, we have the formula Euler-Cauchy equation is, that is y is equal to x raised to mu, a cos nu log x plus b sin nu log x. Okay, x raised to mu, a cos nu log x plus b sin nu log x is there. That is the format of the general solution of the a cos nu log x plus b sin nu log x into x raised to mu, where mu is the real part and nu is the imaginary part. See, dear students, therefore, we can replace the values. Therefore, the general solution y is equal to x raised to, the mu is the real part minus 3 x raised to minus 3 into a cos nu log x, who is the nu is the imaginary part 2 log x, okay, a cos 2 log x plus b sin nu log x is 2 log x, okay, fine. Now this is the general solution of the given auxiliary given Euler-Cauchy equation is the general solution of the given. It is the general solution of given Euler-Cauchy equation. Is the general solution of the given Euler-Cauchy equation. Okay, fine. So this is the methods, and we have we discussed it is that here we can write auxiliary equation for Euler-Cauchy homogeneous differential equation. From that auxiliary equation, because that auxiliary equation is a quadratic equation in M, maybe sometimes some were using lambda or some other letters also, no problem on that case. And also we will find the value of M. There have 3 choices. Maybe the value of M is real and distinct, maybe the value of M is real and equal, maybe the value of M is complex conjugate, mu plus or minus I nu. In all cases, if M is real and distinct, the general solution is y is equal to x raised to m1 plus c1 x raised to m1 plus c2 x raised to m2. See, if m is a double root, real double root, then y is equal to c1 plus c2 log x into x raised to m is the general solution. See, if they are the complex conjugate, m is equal to x mu plus or minus I nu, then the general solution is x raised to mu into a cos nu log x plus b sin nu log x is there. See, my dear students, they have many choices and many problems are available for homogeneous Euler-Cauchy differential equation. Try to solve all such type of the questions, and we will discuss some more questions of Euler-Cauchy equation in the upcoming session also, in the next session also. Thank you for watching this video. Continue watching. Thank you very much.